Okay, so we are live. Hello, everybody. Class of today will be focused on implementing the Deferred Renderer, this algorithm we're going to see this week. And first of all, I want to show you the benefits of this algorithm. So before I start explaining all the nice things about this algorithm, I'm going to bring an implementation I already have, so you can see it. So here I have this implementation. Okay, I don't know if everybody can see well the screen. So this is using the same engine, but I added well all the features that we needed. Um, More or less, it has the same features from the previous one. But I want to show you something interesting here, which is well, first it's a benchmark scene. Benchmark scene means that there's a lot of objects on the scene and lights, so the performance, well, it's a little bit more demanding, and that way I can measure better if everything goes well or not. Don't take much care about the frame rate because I'm recording, and because I'm recording now, the frame rate obviously it's been affected. But you can see that using the forward renderer, it's doing 38 frames per second, which is very low. And also the time it takes to render is 23 milliseconds, which is a lot. And also the number of draw calls is 12,000, so it's a lot of draw calls, okay? But I'm going to switch now to the ferret because I have here an option to switch to the ferret. And if I switch to the ferret, boom, you'll see how the frame rate has improved a lot, how the draw calls have go down a lot, and the time is split in half. But also I have to say that one of the problems with my deferred is I only render in deferred my opaque objects, not the alpha objects. But if I remove the alpha object from the scene, you will see how it goes now to the 60 frames per second and the very slow time, and the number of draw calls is very low. It's 385. Okay, check again. If I put again the forward, the one that you already have, is going to skyrocket to 5,500, and if I go to the third, it's only 385. Okay, so way faster, and you can see that the render now goes a little bit better. Okay, so that's why we want to do the third. It's super fast in comparison to forward. I also have to say that for forward, I'm using multipass, because I'm using multipass, it's a little bit slower than using single pass. I don't have single pass implemented in my demo, so I can show it to you. But the idea here is just to have a benchmark to see in any moment which runs faster, if it's forward or it's deferred. Obviously, deferred should be faster. And also to be able to see if there's discrepancies on the screen. No? If there's something that looks not exactly the same. I have a key on my keyboard to switch between deferred and forward. And you can see if I switch back and forth, it's almost the same. I don't know why. By the way, sorry, there is a glow. Sorry, I need to remove this. There's an algorithm I put on top. And you can see that the colors are more or less the same if I switch back and forth. There's a little discrepancy, which makes sense because when you use deferred, you lose some data when you quantize the data. But still, it goes way better. Okay, so let's see how we implement that. Before I go that, just a quick reminder, we're rendering in two phases. Okay, on the first phase, we're generating the G buffers, and it's good always when you make a deferred render to have a way to show the G buffers. So if I go here, I can show you the 4 G buffers. So starting with the albedo one. This buffer contains the color of every pixel on the screen. What's the material? Okay, so the classical material color. Then we have a normal one, which contains the normals. Don't pay attention to this area outside of the screen, because when there's a skybox, I don't render anything, and because I don't render anything, there's trash on the screen, but it's okay because I'm not going to read this information because there's nothing there. Okay, it's the skybox, so I don't care. So, and as you can see, if you get very close, that you can see the normal maps, like you can see all the tiny lines. You can see if I remove the normal maps, how the difference with and without the normal maps on the normals. So that's good. So we can see the normals looks nice. And finally, I have the emissive channel. So here you can see all the tiny lights that has emissive. Okay. And there's more information. There's information hidden on the alpha channel, but because when I'm showing here the channels, I only showing you the color channel, the RGB, you don't see the alpha channel. But I have here an option to showcase the alpha channel. So if I show you the alpha channel, you will see here that I'm storing the occlusion. Okay. if I go to the next buffer, the next texture, normal, I'm storing here I think this is the roughness or metalness, I don't remember now. And on the third one, I'm storing the metalness, okay? So more or less, I have all the information I need about every single pixel, about all the information. And also, obviously, besides all these things, I also have the depth pass, where I have here the depth, as you can see here, okay? And from this depth and using the inverse view projection, I can reconstruct the wall position. So I have also this option to show the wall position reconstructed from the depth. I mean, it's the same buffer, the depth buffer, but I have a different way to show it. So if I show wall position, you will see how, well, it tries to show you the color of the wall position, but because the wall position keeps increasing, it will saturate very fast. I use the mode, so it means that it goes increasing, and it goes back again, increase, and go back again. So this is a way that some people does to show the wall position when you want to debug a little bit. Okay, so if you don't understand what you're looking, it's okay. It's just a way to transform X, Y, Z on colors in a way that it doesn't get saturated. As you will see, when I move the camera, there's some glitches sometimes. This is due to this point over here is at height 0, and because it's at height 0, sometimes depending on the precision, it's above 0, sometimes it's a little bit below 0, like minus 0.0001. And because of that, it goes to the, well, it clamps and goes to the other color. It's okay, don't worry about this, okay? And as I said, if you don't understand this, maybe you will understand better. Let me show you so you may understand a little bit better. And if instead of showing the wall position like that, 1 second, wall pose, I'm going to switch the shader a little bit so you can see a little bit how it looks. 1 second, because I have to search for the shader. Here it is. Okay, so instead of doing the mod, I'm going to remove the mod. So let me show you. 1 second. I have here my shader. Okay, so now I'm going to reload. So this will be the wall position as you understand it usually. So here we have the 0, 0. And from here to the right, the wall position is increasing. But because it's increasing, it goes to 1, it goes beyond 1, and then it saturates to 1. So I can divide it by 1000, for instance, the position. So this gradient is a little bit better, okay? And this is a way to visualize the wall position, but still, I mean, it works well in the range between 0 and 1, but beyond that range, you don't see much, okay? So you can see this is the wall position because, well, I don't know, the higher it is more green, the more to the right is more red, and the more to the front is more blue, okay? Anyway, as I said, it's always nice to have solutions for debugging, and it's always nice to have a way to visualize this data, okay? So let's go back to my regular renderer here, and you can see we have our nice renderer that runs 60 frames per second, super nice. Also, this monitor is capped at 60 frames, so we cannot go faster. Okay, so let's close this, and I'm going to go back to the slides, obviously. So let's check here, okay? So what we were saying is we are going to need mostly a place to store all these these 3 textures, plus the depth texture also. And so this is what we call the G buffers, okay? So I'm going to go to here, okay, and to my renderer, we already know, and we already have a render mode here, by the way, we have this one. So it's not time to add or deferred. Oops. So we have an option, and always, every time you add an option, always remember to add it to the UI, so you can, in any moment, if you need to go to modify this option, here I can say deferred. Okay, so we have 4 options and 1 is deferred, so that means that I can switch it in any moment. But also, because I'm going to be changing this a lot constantly during the course of today, doesn't make much sense that I start always with the light mode. So let's start with the deferred mode, okay? So when we have to render the scene, I'm going to have to render the frame, and here I'm applying the thing we did the other day, which is rendering every node, blah blah, the skybox. Okay, this only makes sense if we are using the regular renders mode, which was the lights mode. Okay, I don't know if I put here, where did I put the, oh, I put it here. Okay, this is kind of a crappy solution, but anyway. So I'm going to put here, if render mode is equal to render mode deferred, then I'm going to go in some direction. Otherwise, I'm going to use this. Okay, so let's call it render deferred, which is a little bit ugly. I don't like to do this. Sorry, I'm going to do it a little bit different because I need to clear up a little bit the code. This is, I mean, it says render frame, which is a nice function, but it's hard coded to forward. I'm going to separate a little bit this. So render frame is going to call, depending on something, is going to call render forward. Okay, so this is render forward. I'm going to pass the scene and the camera. Okay, so if render mode is equal to deferred, I will call one, and otherwise I will call this one. Okay, this looks better. Okay, so I have to construct these functions. It's okay. Let's go here. So we are going to have a forward one and a deferred one. Okay, cool. So now this should work well. I have both options and I can switch, but we need a body for this one. So for the deferred one, it's going to be a little bit big, I can tell you now. So I'm going to put it after the other ones, like, I don't know, here. Okay, I can tell you that in my engine, it's a little bit different, the one I was showing you before, because I like to reuse render pipelines in different steps. So I usually don't pass the scene and the scene directly. I pass here the render calls container, the std vector with all the render calls. And I think that's much better because if you pass the render calls vector, that means that you can reuse, like for instance, I can render the alpha objects with the forward pipeline, and I can render the opaque with the deferred, things like that. But for now, just have a totally different one for every kind of case. So render deferred, we have, as I say, two passes. The first pass, generate the G buffers, and the second pass, compute the illumination. Okay, so we have here, oops, these two steps. For the G buffers, we are going to need an FBO, and we are going to need to that FBO that has many layers. So obviously we need to have a texture here, an FBO, blah, blah, blah. So I'm going to make it global because I'm going to need to show it and access and all those things. So for now, by the way, there is an error on the engine here. I modified it the other day. I will do it now, but I will tell you, I forgot to add this function, upload to VRAM. You will see why I need this, okay? But if you have your framework around, add this line to the code. And this will improve the performance a lot when we are doing the ferret. The reason is we are going to render a lot of spheres for every light, as I was explaining yesterday. And I forgot that when you create a mesh, if you don't specify anything, it's not going to be stored on the GPU. It's stored only on the RAM of the CPU. And every time you render that sphere, it's going to send every single time the mesh data to the GPU, every single render. And that's super slow. In the framework, every mesh that you load always calls this function, called upload to VRAM. What it does, this function, is going to create buffers on the GPU, and it's going to upload the data to the GPU. So it's sending data of the vertices, the UVs, the normals, everything, sends it to the GPU and stores all the data in the GPU. So in the future, if you want to render anything, it's going to use the data directly from the GPU, which is way faster than sending, I don't know, all the vertices and UVs every frame, okay? And by default, I call this function on all the meshes that are loaded, but I forgot to call it when you generate the mesh, like here, I generated this mesh. This function is not good to call it if this mesh is going to only last one frame. If you're going to create a mesh, use it to one frame and throw it away, then this is worse because you are allocating memory on the GPU, uploading there, and then destroying from there. Okay, but this mesh, we're going to use it a lot. This is sphere mesh. I added on the engine, so that means that we better have it here. Okay, so so the mesh, by the way, is here, this mesh sphere. Okay, so I was saying, we're going to need FBOs. Okay, so let's create an FBO, G buffers, FBO. And by default, it's going to be a null pointer. But obviously, in one moment, we will have to fill it. And also, I can advance you that we are going to need a illumination FBO, where we are going to render all the lights at the end, okay? We can do this we shouldn't need to use the illumination FBO. We can do it directly to the screen if we want to. But I want to do it in a different container for now. I think it's a good practice because maybe we need to apply some extra effects to this final illumination FBO. So we will see. So we have now our render deferred function, and here we have our FBO. By default, it's going to be empty. So obviously, we're going to need to do a new GFX FBO. And when we create the FBO, there's two options. You can attach textures that you already have. If you have a texture, you can attach it. But I gave you already a function to go faster, which is that you can create the texture. So in this case, I can say, hey, I want to create several textures to store the information about the pixels. What's the size of this FBO? Of the texture? Well, the size of the screen, obviously, because we need to store all the properties of every pixel. So let's get the size of the screen. There is a function, guys, call it core gets window size. So we're going to use the window size, and also I have to specify, I don't know if you can read it, the number of textures. Okay. So that means that how many textures will have this FBO. We are talking about 3 textures for the colors, like color, normal, and emissive, and 1 extra texture for the depth. But the depth, I'm not going to put it here because it goes in the next, at the end, you can say use this texture and it will create 1 depth texture automatically. So you know how to do it, okay? The format, how many channels? We need 4 channels. Okay, because we want to pack as much information as we can per pixel, so having 4 channels is good because then we can use the alpha as I was using before for the metalness and the roughness. And finally, how many bytes per component? In this case, I'm going to use unsigned byte, okay, although some people say it's better to use more bytes per component for having better normals, having better emissive, for instance, or emissive now only can go from 0 to 1. What happens if we want to have something very shiny? We will see that on the future. But for the albedo, it usually goes from 0 to 1. The shiny, the metalness, roughness, all goes from 0 to 1. So I don't want to waste bytes because the more bytes you require to render, the more time it takes to render because the buses are more busy transferring data. Okay, so cool. And finally, the last parameter says you want to use a depth texture. I'm going to say true. By default, it already puts true, so there's no need to do that. But it's a good practice. Okay, keep in mind that I'm creating the FBOs with the size of the screen, and I only create it once. Okay, that means that if in the second time I render this scene, I'm rendering this scene like several frames, and I change the window size, it won't look good because it will stretch the pixels. Okay, like if I change the size of the screen, I should destroy this FBO, create a new one with a new size. I'm not doing that for now, but maybe you want to do it if you want to allow the users to resize the window, maximize, etc. Okay, just for convenience, I want to go fast. Okay, so we have a place to store all the data. Then store some data. First, we're going to bind this FBO. That means from now on, we are rendering inside the FBO, not outside. Cool. So we have a way to measure now to render inside the FBO. What should we render here? We should render every single object of the scene, but we want to store 4 or 3 values per pixel. The albedo, the emissive, and the normal. Okay, so let's start by the basics. I'm going to clear the buffer bit, and the def buffer bit. Okay, remember that this is the classical instruction to clear everything. So we start from scratch. The problem is that when we clear the color bit, remember when you clear, you call this function GL-clear in OpenGL, is going to clear the color of the frame buffer with the color specified by GL-clear color. Okay, this one over here. And that's a problem because first, I don't want to store, well, I can store the background color if I want to. But anyway, what I wanted to say is that if we clear the color with this background color that gets specified by the scene, it's going to clear all the color buffers with this one. And that could be a problem. Maybe we want to clear the first buffer with, I don't know, black, and the second buffer, the normal buffer, with another color. I don't know. So if in any moment you want to do a draw call, or any action that changes any of the buffers, but you don't want to apply this action to all the 3 buffers on the G buffers, like only to the first or to the second or to the third one, I gave you a function for that, okay? There's a function here, call it enable single buffer, or enable buffers, I think it's called enable buffers. Yeah, it has 4 bools, so if you put true the first one and false the others, only will modify the first buffer, not the other ones. So in this case, because I only want to clear the color for the albedo, you can do something like this: true, false, false, false. Okay. And after that, we are going to put everything to true. You can put here true, true, true if you want to, or just directly just here enable all buffers again. Okay. So what we have done here using these enable buffers is to be sure that we don't modify, we don't clear the color of the normal buffer and the emissive buffer, okay? Why not? It's not a bit important now, okay? But I don't want to, in any moment, confuse myself and think that that a pixel on the other buffers is important. So maybe you can do this. But for now, if we don't want to do it, don't do it, okay? Yes, a way to remind you that when you clear the color, it's going to apply the same clear color to all the buffers on the G buffer. And the G buffer has 3 buffers, so it's going to apply to 3 buffers, okay? Cool, so now everything is clear, and we need to render the whole thing. So we need to iterate through every node, and in every node, call the function to do the render using a special function of the material, okay? Because I didn't do the render calls thingy, now it's a little bit ugly, okay? So I'm going to have to do something a little bit more ugly. I'm going to call this function render node, which is the function that goes through everything and renders, which I don't like to do it this way. As I say, my code is way simpler, but I didn't implement the thing. So I'm going to have this other function called render mesh with material G buffers, okay? And it's going to be similar to the other ones, but its action is going to be, and let me put it, go back here. This function, the only thing it's going to do is going to render the objects, but without any light, only to the G buffers. So at the end, I have every single pixel of the screen. I can read the information about every single pixel, the properties, like what's the color, what's the emissive, what's the normal, blah, 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 okay? So I'm going to put right below my render deferred function here, okay? And it's going to be very similar to the other ones, but it's more similar indeed to the one that is, I call it textured. So let's go to the one called textured. This one was the textured one, yeah. So I'm going to copy this one. I think it's a good starting point for our function. So let's go here and not light, sorry, G buffers, yeah. Okay. So remember this basic function, what it does, it just renders the albedo, the emissive. I don't put the normal here and the metallic roughness, occlusion, all those things you will have to do it by yourselves. And it's going to apply alpha. You can see here there's a lot of things about alpha, but remember that when we render in the deferred buffers, we cannot use alpha because alpha means that I want to blend 2 pixels, but it doesn't make sense. I don't want to blend the normals or blend the albedos or blend the roughness, okay? Deferred doesn't work with blending, not because it's going to explode the machine or the GPU, it's just because it doesn't make any sense. It doesn't make any sense that if I read 1 pixel, I want to know that pixel on that Z position, on that wall position, I want to know all the properties. But if I have blending, it means that I have half properties of different objects, so it doesn't make any sense. So anyway, no blending, it doesn't make any sense, okay? We're going to need if it's two-sided or not. Yes, we're going to need to enable the def test, obviously. But we're going to use a different shader. Let's call it the buffer. Okay, and we are going to enable. We're going to pass all the information as we did before, the color, the emissive, the albedo texture, all the information here, exactly as we did before. The alpha cutout, all of it. And if it's wireframe, it doesn't make any sense here. But anyway, and we are going to render, and that's it. As you can see, it's almost the same because, I mean, we only have to send all the information about the material to the shader, okay? But obviously, the difference is in this shader. What's this shader going to do? And as I said, it's very similar to the other shader, the texture shader. So we can use this one here if we want to. So let's call it G buffers, okay? And G buffers. So it's this shader here. Okay, so we are going to go to texture FS, and I'm going to clone it because it's more or less is the same I want to do. I don't have the emissive here, but well, anyway, I will add it if I have some time. Okay, so the difference is that this shader, we want to be able to draw to different textures. Not only, you can see here that it's only drawing the output goes to this frag color, and we're only drawing one buffer. When you render with multi-buffer, if you only render to one buffer, the others are not going to be modified, and that could lead to strange situations. Okay, so in this case, what makes more sense is that I output to many buffers. So when you want to output to many buffers, I put you an example here, call it the multi-FS, so you can see it. This is the syntax. So you specify on the layer number 0 is the color, on layer number 1, I don't know, is the normal, on the 3 is the emissive, okay? And then you can, when you fill this, it's going to fill different textures from the shader, okay? So now I can go back to my gbuffers function here, and I'm going to specify I have not 2 but 3 buffers, okay? The third one, you can call it emissive. I'm going to call it extra because I think it's easy to remember. Because instead of emissive, maybe I want to put more than emissive. I want to put all other properties of the light of that object. So let's call it extra for now, okay? So the frag, the normal, and the extra, okay? For the color, we already have this. We read the texture and we put it on the color, multiply by the color of the object. For the normal color, I want to put the normal here, okay? But remember that first, every of these components has 4 components, so I have to specify these 4 components. Then I need the normal. Do I have the normal? Yes, I have this normal here. But remember that this normal has 2 problems. First problem is that it's not normalized due to the interpolation. So first, always, it's good to do this. Okay, so now I have a normal that is normalized. I'm going to put it here. And second, the problem is that this goes from 0 to 1. And sorry, from -1 to 1. Normals, remember that it can be negative from -1 to 1, and that's a problem because colors can only go from 0 to 1. So we're going to use the classical trick where we multiply by 0.5. So now the normal, instead of going from -1 to 1, goes from -0.5 to 0.5, and then I'm going to add 0.5. Okay, that way it's going to be from 0 to 1. Doing this, I have lost a lot of precision because I'm storing this in a 1 byte, and 1 byte doesn't have only have 256 different values. 256 different values. If we split the negative and the positive part, that means 128 different values of positive and 128 for negative, which is not so much, but it's okay. And for the alpha channel, I'm going to put 1. Okay, and the same here for the alpha channel. I only care about the RGB. I'm going to also put 1 here. Although here I recommend you can start here if you want to the roughness or the metalness or the occlusions. Okay. And for the third one, the emissive or the extra color, I'm going to have here the emissive. Okay. As you can see, I don't have still the emissive, so we better load it from somewhere. So we need the texture for the emissive. So here, and this is from the light that we did today. I'm going to copy. It's called albedo texture. I didn't call it a color texture. Okay, cool. So let's go back to my code. Here it is. Okay. So instead of this, not call it texture. It's called albedo texture. Let's go to my shader to see them. Yeah, I called albedo texture. Good, I realized. Otherwise, I would not have found the texture. And then the color, the albedo texture is when I read this texture. The U color is the color material, and the emissive texture I have to also load it. So I'm going to load this emissive texture, because the emissive texture doesn't have 4 components, only have 3. I don't need to read the 4th component. So I have this emissive, but remember that this emissive, I want to multiply it also by the emissive factor, because the emissive factor is the one that tells me, modulates this emissive thing. So you can have like a white texture, but you can change the emissive factor to make it red if you want to. So I have here the emissive, it's here. So that's it. I mean, if I render now, I should have in one buffer the color albedo, in another buffer the normal, and in another buffer the emissive. Okay, and that's it. I mean, this is most half of the deferred, that you can see, quite simple. So I don't think I'm missing any data here. I'm sending everything. So yes, I need to call this render node function as we did the other day. I should pass the scene root node or whatever. How did I call the render node? Ah, no, I need to call this one over here. It's called render forward. Oops. Let's separate this one because I need to call it from render forward, but also from other ones. Then render, I don't know, scene nodes. If you have the render calls, this will be much simpler. But because I don't have the render calls, I have to use this ugly code. So this is going to go through every entity and call the render node function. Okay, yeah, okay, it's not good. Maybe the next day I will add the function to do the render calls, because otherwise some of the examples I want to show you and they look way worse. So here I can do this. Okay, so this is the same for render forward. We call render nodes. Okay, but now the nice thing is I have the option to call also this function from my deferred. So deferred. So here I can call this function to render all the objects. Cool. So if everything goes well, I have my gbuffers generated. The problem is I cannot see them. Well, I can halfway. I mean, I cannot see them perfectly, but let's start by testing what's happened if I execute this one now. So I don't see anything, obviously. If I go to the texture or to the lead one, they work, but for the deferred, I don't see anything because I'm generating the gbuffers, but I'm never showing those gbuffers. But you can see them if you go here to textures and you go down. They should be around here. No. Okay. I forgot to do something because they should be here, but there's nothing here. Okay. Let's go, and one of these is the def buffer and the other are the colors. Okay, couple of ideas. First of all, I never enabled the camera. As you can see, the camera is never enabled. So probably that's one of the first problems. So I have the camera here. So maybe I should enable this camera to be sure. And that's the first thing I should have done. I forgot to do. And let's try again to see what happens. Okay, go to the view textures, go down, and haha, there it is. Okay, you can see it's upside down, by the way, because in the GPUs, when I render these textures, anyway, there's always the problem that for this interface, 0, 0 is here, but for the OpenGL, is 0, 0 is here, and that produces the image are flipped. Okay, maybe I will add a flag here if you want to flip them, but we have the gbuffers. It's hard to see them upside down and this small, so I would recommend you always that have a function to visualize the gbuffers. Okay, it could be a function that visualize them, like you can choose which one you want to show, as I was showing you before using the imgui. Or if you want, there's another option I usually use, which for me works very well, which is just having here like a flag. Let's call it show buffers. I will add it later. And what you're going to do is, first, if I want to see on any of the buffers, remember that I can go to the gbuffers FBO, oops, and I can say, hey, all the colors textures inside here, this is an array, I want the 0, okay? And here I can say, I want to show it on the viewport, okay? If you do this, it's going to take the first texture of the gbuffer, and is going to just make a quad and draw it the full screen. Okay, and this is very handy because then you can see, I can see now the albedo texture. Okay, interesting things apart, you can see here an interesting thing, which is that the alpha objects are rendered without the alpha. Remember that my function gbuffers and render gbuffers. If something has alpha, it doesn't use the alpha. The problem is that if something has alpha, my function shouldn't render from the very beginning. I mean, so this function here, if the object has alpha, and I'm going to put it here, if this material, the alpha mode is equal to alpha mode blend, then nothing to do. I don't want these objects because they have alpha, and I can render without alpha. If I want it, I can render them, but then I will have to render them using the Deferred I was showing you yesterday, which is drawing some one pixel I draw it, one pixel I don't draw it. Okay. For now, I'm not going to do it. For your assignment, you will have to do it. So it's just adding a flag on the code to do that. It's not very complicated. And the code is on the slides, obviously. So here now we have all the opaque objects, as you can see, on the buffer. But I want to see other buffers, okay? So if I want to see, for instance, the normal buffer, I take the first buffer, the second buffer, the number 1. And here it is, the normal buffer. Cool, I can see the normals. And I can go with the third one, which will be the emissive. And if I wanted to show the depth buffer, let's see if it works. The depth buffer is here. Sorry, depth texture. I also can see the depth texture. So one common thing when you're rendering the ferret is to render the 4 buffers at the same time on the screen. So here is the depth buffer, but remember the problem with the depth is that because it's not linear, it's very hard to visualize. So you won't be able to visualize it very well because it's not linear. So there are a shader that you can use if you want to visualize this. But for now, what I want to do is I want to render the 4 buffers on the screen. So one trick is you do GL viewport. Okay, remember that GL viewport allows you to render to one specific area of the screen only. So I'm going to say I have the window size here. So I'm going to say, hey, render from 0,0 to size.x divided by 2 and to size.e divided by 2. Okay. And at the end, I'm going to put the buffer back to size x and size e. This is to render to the full screen again. So for instance, if I do this, I'm going to put here the color. You will see that it's going to render the G buffer on one of the corners of the screen. Okay, so here it is, the G buffer here of the color buffer. I want to use the other ones for the emissive, the normal, and the depth buffer. Okay, as you can see that the 0,0 is not top right, 0,0 is bottom left because it starts counting from bottom left. So maybe you want to put this one, the first one, then I would recommend you that you put here this. Okay, so it's going to be starting on the upside. Then I want to render the next one, which is going to be the size X. Then I'm going to move it half size to the right, and I'm going to render the normal one. So now we have the color on the top left and the normal on the top right. You can see it. We have the color buffer and the normal buffer. Cool. And then we are going to do the last one. Here is going to be the emissive one. So this is going to be 0,0. And finally, I want to show also the depth buffer. So let's go and put the depth buffer on the right side. So, okay. The problem with the buffer, we won't be able to see it because we need a shader that linearizes the set. But I give you that shader, by the way. If you want it, it's called GFX shader. Get default shader. And there's one called linear depth, I think I call it. Let's check it because I never remember, but it's always good to have it. So linear depth, here it is. And remember that this one expects that you pass the camera near and the camera far. Okay, so I'm going to need this parameter. So I'm going to enable the shader. Sorry, enable, yeah, no, shader, what, no, sorry. Enable the shader, and I'm going to pass to this shader. I'm going to pass the camera near and far, because to linearize the set buffer, here, to linearize the set buffer, you need to know the near and far planes. If you don't know those you cannot do it. So here it's I'm going to send a vector 2, where I have the near plane and the camera far plane. Okay, this shader requires these 2 values, otherwise it cannot linearize, because depending on this it will be differently linearized. Okay, cool. And if I do this and everything goes well, and I have the 4 buffers visible on the screen to the back. Okay, so 1, 2, 3, boom, 4 buffers, and I can see the set buffer. I can see the emissive buffer. You can see here the emissive of the sign, the albedo, and well, anything. The only problem I'm missing is the alpha channels. I'm not visualizing the alpha channels of these 3 buffers. And the alpha channels has important information. The alpha channel of here, maybe I want to store the roughness, here the metalness, here the occlusion. So this visualization only shows the RGB channels, not the alpha channels. Maybe you want to have a special associator to only show the alpha channel and not the RGB, as you want to, okay? If I want to show all those ones, well, then I will need to pass maybe here a shader that only does show me only the alpha channel. Okay. So we have a way to visualize these buffers, but we don't want to visualize them. We want to use them. So here maybe we show G buffers. Maybe it would be a nice variable to have it if we want to toggle things. So show G buffers. By default, these G buffers are not going to be shown. So false, but maybe on the show UI, you want to have a flag to control these parameters. So okay, so I have added an option to debug, and it's always good. It helps when you're working to, in any moment, you say, hey, I want to see these G buffers. So I don't see anything now because I'm not using these G buffers or anything, but if any moment I want to see them, I go here, boom, here are the G buffers. It's good to see them to be sure that what you're seeing is what you expect to see, okay? Otherwise, you may end up, well, complaining that you don't see some stuff. Okay, cool. So first part, generating the G buffers, done. Super simple. Now comes the tricky part, which is how we fill those G buffers, so how we use those G buffers to render the scene. Okay, so let's go back to our render deferred, which is here. Okay, so now comes the next part. So for the next part, I'm going to render. I can render to the scene, to the screen if I want to. I created a buffer there before, but for now, just do it to the screen, and then we will do it to the buffer maybe. Okay, so now we have to start our scene. So I clear the scene, the def. I don't really need to clear the def as far as I know because I'm going to rewrite it, but anyway. Okay, so I need to render here the full scene. I will recommend you, and this is handy, that now on the screen, the def buffer doesn't contain anything. The def buffer in the G buffers contains all the def, all the information about the distance of every pixel. But on the main window, on the main frame buffer on the screen, the G buffer is totally empty. And that could be a problem because if the G buffer is empty, that means that if I want to render an object using the Z buffer, it's not going to work. So the first thing I need to do is copy the Z buffer from this to the Z buffer of the screen. Okay? And copying Z buffers is not, well, straightforward. I'm going to make a shader for that. I can use this shader also to render some of the basic thing, which is for instance, the ambient color, the emissive color. So let's start by creating one pass that's going to render a full screen quad. Okay, I'm going to render this full screen quad, and I'm going to use a shader where I'm going to, for every pixel, I'm going to set up the initial state I want of my frame buffer. Okay. After that, I will render many other passes for every light, but I need to start the buffer with something because otherwise now it's empty. The screen now is empty. Okay. And one way to start is to render the global things that are not dependent on lights. For instance, the ambient light, the emissive light, the skybox. So you can see there's many things that we can render. Okay, so maybe we can also even render the skybox if we wanted to. So here, for instance, skybox cube map if I wanted. So let's see here. By the way, the camera is still enabled, but I'm going to enable it again. I know it's silly, but just in case I change something in the future and modify the camera. And only have to do this if there is a skybox texture, otherwise nothing. Okay. So for now, if I execute, I only should be able to see the skybox, nothing else. Okay, so I have here my skybox. Okay, nothing else. There's no geometry here, so there's nothing to see, no geometry. Okay, but now I'm going to render a full screen quad. When you want to render a full screen quad, you need the mesh for the full screen quad. This is called usually, I call it quad, and you don't have to generate it because it's already generated for you. Get quad, Okay, this is a text, a mesh. It's a very simple mesh. I saw it. I told you the other day. It's a quad that goes from 0, 0 to 2, 2. Well, it's not exactly that. The center is in 0, 0, but the size is 2, 2. So that means that here's the 0, 0 and goes from minus 1 to 1. Okay, because it's centered. And I also obviously upload to the VRAM because I'm going to use this quad a lot. So this saves a lot. Okay, so now I can try to render this quad with a special shader. Okay, so let's start by creating a very simple shader for this quad. Okay, so first of all, the question, and this is a very common error, lots of you will copy one of these shaders here to do the quad. Let's call it Deferred global, because it's the global illumination, it's the global information. Okay, and Deferred global. The problem if you do this is that you're using this vertex shader, and this vertex shader will expect that there's a model and there is a view projection, but this quad is already in clip space. So that means that you should never multiply this vertex by view projection on the model, because that means that this quad is in wall coordinates. It's not in wall coordinates. It comes already in screen coordinates. It's already, you don't have to modify anything of the vertices. Because of that, be careful, because if you call this basic VS, it's going to modify. That's why I provided another one called quad VS, that here you can see it takes the vertex and doesn't do anything. It passes the vertex as the, because it doesn't have to do anything, because this vertex is already in clip space from -1, 1 to 1, 1. Okay, perfect. So for my deferred, I'm going to use this quad VS, and then I have to create this deferred global. Okay, so I don't know where to create it. Let's go to the bottom and create deferred global FS. Okay, so what should I render in this quad? Let's going to take, I don't know, any of the this one over here, just as an example, because this is very simple, the texture one. Okay, so this is going to read textures, and I don't need time, need color. I can remove half of all this. I don't need this and this, the wall position. Remember that all this information now is wrong, because we don't have a wall, a vertex position, because the vertex position of a screen quad is the corners of the screen. We don't have a wall position because we don't have a model. It's just a quad is not in wall coordinates. So this doesn't make any sense. The normals, the UVs, we will see how we can get the UVs, but I don't think we need the UVs, because as far as I remember, my quad VS, it passes the, it has a UV, okay, and it's going to be passed as VUV. So yes, I have the UVs, cool. So the UVs and the position doesn't make any sense. So at the position, I don't need it. Okay. Okay, so I can kill almost all of it. Let's start by rendering red, for instance. Okay, so to test, always have something like a red color. So defer global, go here and say, okay, I want to render this quad with this kind of shader. So let's take this shader. Defer global. We enable it, and we render this quad. So quad render. Look at that, we don't pass any data to the shader. We don't pass view projections, models, nothing, okay? For now, just to test it, if we execute this and everything goes well, we should see a full screen quad, which is red. Okay, cool, that's nice. Some clarifications first. You may realize that I destroyed the skybox I was rendering before. It's okay, because the problem with this quad is it's going through every single pixel, and we don't know which pixels are skybox or not, or do we? How can we? I'm going to do something first before I go. I'm going to pass all the G buffers to the shader. So let's call it albedo texture. I don't know, or G buffer. I don't know. Let's call it this, and color textures, the 0, and it's going to go on channel number 0. Then 1, 2, 3 is going to be 1, 2, and this is going to be the depth texture. So let's call it albedo, normal texture, and this extra, and this depth texture. Okay, and I want to catch all these textures from the shader, so let's go to the shader and catch them. So here we have the albedo, we have the normal, we have the extra, and we have the depth texture. Okay, cool. So first question, just to see if everybody falls asleep, I'm going to throw a question. Be ready, prepare your minds. How can I know which pixels are skybox and which pixels are not skybox with the information I have now on this shader? Think about it. Because now if I render this quad, it's going to render everything red. Okay, and I want to skip the parts of the screen where the skybox should be visible, the pixels that were not geometry of the scene. Okay, so when I'm in this shader now, with the information I have this in the shader, how can I know if a pixel is a skybox or a pixel is not a skybox? Thinking about the information I have here, obviously. Okay, Skybox doesn't have depth texture. But first, Skybox doesn't have a depth texture. It's a good approach. I will reformulate a little bit. So depth texture is just depth texture. I mean, remember that this texture is not per object, okay? I mean, this texture is for the whole frame. So it's not like the objects have textures now. We have information about the whole scene. Matter that it's infinitely far away. Okay, so what Andre is saying makes sense, but you have to reformulate in a different way. I can read any of these textures. I mean, I can read for if I want to read any of these textures, I can go, I don't know, for here, color equal texture, any of these textures, I can pass here the UV, okay? I can read them. The question is, what differentiates the skybox pixels from the object pixels on these textures, or at least in one of these textures? What's the difference? If I read one of these textures, can I know if it's a skybox or not? And David, you were saying the albedo texture, but the albedo texture, remember, that only contains information about the color of the objects. It can say it's black, it's red, it's blue. It doesn't tell me if that's an object. No alpha channel, no, it doesn't make much sense. Read the depth, and if it's very big, then it's very far from not painted. Exactly, Oriol is right. What we need is, if we know the depth buffer, we can read the depth buffer. And if we read the depth buffer, I'm going to have here depth, okay? I'm going to read on. When you have the depth buffer, you can only read the first value, the other ones are the same value, okay? If this value is far away, that means that this pixel is in the infinite, so that means it's a skybox. Indeed, it's not if it's far away, if it's 1, because the depth buffer comes from 0 to 1, it's normalized, okay? So if the depth of this pixel is 1, it's a skybox. In this case, I'm not going to do anything. I'm going to discard it. I don't want to paint the pixels because this quad is supposed to illuminate, but the skybox doesn't have to be illuminated. So if I execute this now, you will see that if it's a skybox, I'm not rendering, okay? Because the depth is 1, it's in the infinite position, so we can skip them. Cool. We have already cleaned the pixels, we don't care. But now we have to render the other ones, okay? So if I go now and read the color of any of these pixels, like the albedo texture here and XYZ, well, I'm going to read the 4 components. Color, okay, I read the 4 components now, and let's go here and put this here, okay? If I do this, I'm reading the albedo texture and taking the information and put it in the color. Yes, we have the unlit one. It's exactly what this had before. And if instead of using the albedo texture, I read the normal texture, then boom, we have the normals, okay? So, I mean, yeah, but now what we want to start doing is exactly what we did previously for illuminating, okay? So let's start step by step. First of all, what I'm going to do is get every information that I may need. Normal texture, no, normal info. I'm going to call normal info, not normal, because maybe I want to hide something on the alpha channel of this texture in the future. So So I want to say that the vector, the normal now is going to be normalize of the normal. It's hidden here, remember, but this normal goes from 0 to 1 and it has to go from -1 to 1. So we do the trick of multiplying by 2 and subtracting 1. That means that now it goes from 0 to 1, it goes from -1 to 1. Okay, cool. So now we have the normal and it's normalized, and so this normal is in wall space. The problem we still face is that we don't know the wall position. It would be nice to apply some illumination and stuff like that, but we don't have still the wall position. But right now we don't need it. Okay, so indeed I don't even need this one and this one now. For this global, we will need it on the next shader I will do. So what I'm going to do is, this is the color, and I want to apply the illumination that doesn't be affected by lights. That means the illumination for emissive and ambient. So I need those parameters. So this information, I don't have it here. So I better pass the ambient light. This is going to be important to have it. Ambient light, and I think that's it. I don't need more information, I think. So I'm going to read the other texture, the extra. So here, extra texture, yeah. So if I, for instance, I want to have only the ambient light, okay, and instead of calling color is a bad name, let's call it albedo, because otherwise I'm going to get confused. So if I have this color, I'm going to say that, let's start by saying that on the color, I want to add the emissive, okay? Makes sense, no? Here, remember that in this texture, we have the emissive, and if we are going to start rendering the emissive, we have to put it in some of the steps. So let's start by putting the emissive on the color channel, okay? So if by the way, I color now, it's 0, the fourth component. Well, anyway, the emissive here, you can see it, okay? So we have the emissive already, okay? Cool. Next step, we need the alpha. Sorry, the ambient, okay? For the ambient, remember that I could do something like this if I wanted to. If I have here the ambient light, I need it here. I can add it here if I wanted, but the problem if I do this is I'm not taking into account the color of the materials, okay? I need to know if this is black or white or whatever color. So here, this should be multiplied by the albedo of the material. If I do this, boom, we have the very basic thing. We have the ambient light and the emissive, okay? And also the skybox. Cool, we are going the right direction. As I said before, it would be useful to have the depth buffer initialized with the right depth. You may think when you see this image that the depth buffer now of every pixel on the scene is the right value, it has the depth, but it's not true. I mean, because I'm rendering a quad that doesn't have any depth, and I'm not modifying the depth when I render the quad. The depth buffer now it's infinite in every single pixel on the screen. Okay, we have the depth buffer on the other texture, the one where we generated the G buffers, but now on this one, the one we're rendering now at the final step, the G buffer is totally empty. There's no information, which is not a problem for us. But if we are going to render those spheres I was talking yesterday, we need to be sure that the depth buffer here is the right one. So the last step I forgot to say is that we, besides changing the color, we should also change the fragment depth. Okay, this is a function, frag depth, that allows you to specify what's the depth of this pixel, and the depth of this pixel obviously is going to be this value. Okay, I don't know if I mistaken the name. Reloaded. Yeah, it reloaded again. Okay, so it looks exactly the same, but now the depth is right. So if I render a sphere now, the sphere will match. I can make you a test if you want to. So let's do a quick test so you can see it. Okay, I'm going to go to my renderer, and after rendering all this illumination, blah 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 blah, I'm going to use the sphere. Okay, and I'm going to render the sphere. Okay, render the sphere, but I'm going to use a different shader because this shader, it doesn't make any sense. Oops. And I'm going to use, I don't know, for now, a flat one. Remember that the flat one renders in a flat color. And for this one, I need to pass, obviously, all the camera things. Remember that we have a camera to shader function. Oops. Camera to shader. And this may be handy. Where I am here. Yeah. So I'm going to, oops, I killed the shader, damn it. Flat. Okay, and the model, I need a model, so let's go here and say I have a model which is identity. I want to make it a little bit bigger, so let's scale it by 10, 10, 10, so it's a little bit bigger. And so we have the basic things. The only thing missing, by the way, is the color, because the flat shaded needs to specify some color. So I'm going to say, I don't know, red, without any alpha. And because I want to take into account the def buffer, I'm going to say here, hele enable GL def test. Okay. Also, when you render the gbuffers, always remember to disable the def test and the blending, because if it's enabled, it's going to do crazy things, and with the blending the same. So always when you render two things, always be careful with the state of OpenGL. So here, we are rendering the full screen quad, and now I render a sphere, okay? And if I render this, execute this, it's crashing because I already defined a shader. I know, let's not redefine the shader. It's crashing again because I also redefined a shader here. Okay, out. And now it's crashing because I forgot here to add this. So that's good. Okay, so what is the sphere? That's weird. There's no sphere here. Ah, yes, it is. Look, sphere is here. But that's not what I was expecting. I was expecting that because I rendered the sphere, the last thing should be on top of the screen. But it looks like he thinks that the Z buffer of everything I render, it's closer to the camera. Just to be sure I'm not doing anything wrong, yield the func is going to be less. And I may be doing something wrong. 1 second, just to be sure. When I render this quad, I don't want to have the def buffer enabled, nor the blending. So I don't mess around with blending or anything like that. Okay, that's weird. That goes again my intuition, because if I render the sphere with def buffer, it should think that this sphere it's in front of everything, because by default the def buffer is far away, and if the def buffer is far away, when I render the sphere, okay. No, wait a second. Disable def test, render skybox, and no, when wait a second, I'm modifying it here. Oh yes, I'm modifying things here. Damn it, I'm enabling the def test after render the skybox. Damn it, I shouldn't have done this. So I'm going to disable this thing, the def test after this, sorry. Now this makes more sense. Okay, I'm going to explain you what was happening. When we rendered the full screen quad, it was right into the depth buffer, and because the full screen quad is very close to the camera, when I render it, it was like putting all the Z buffer to the very close to the camera. Okay, this is what I was expecting. Okay, when you render a full screen quad, you usually don't want to render to the buffer because it doesn't make any sense, because it's a screen quad that it's on very close to the camera, in front of the camera, so the Z is always going to be like 0. So here, as I was saying, I have this sphere, and because it's not taking into account the depth buffer, you won't be able to see which parts of this sphere are built behind or in front of anything, okay? But we can fix that very easily. If I go here to the shader and try to modify this, like adding this, it won't work, and I will show you why, okay? As far as I know, it shouldn't work. Yeah, it's still not working. The reason why it's not working is because when I'm rendering this full screen quad, okay, I have said disable def test. If you say disable def test, if this shader modifies the def buffer, it's not going to modify the depth buffer because it's disabled. Okay, so I want to have a depth buffer, but anyway, if I enable it now it should work because it will be enabled, but I will push the set not very close to the camera, but I will push it far away using the depth of the other one. So if I do this one now, you can see now this sphere is taking into account the depth buffer. Okay, so just a quick recap so you get lost here. Before I was doing this, because I wasn't doing this by default, it was pushing the depth to the depth of the plane. And the depth of the plane, because it's a quad screen quad, it's 0. So that means I was putting all the pixels to depth 0. Now I have this line here, so I say, no. Don't use the depth from the triangle I'm drawing on the screen. Use a depth I'm going to tell you from the shader. And in this case, I'm telling the depth that I read from the depth buffer I rendered before, so I'm overwriting that depth with the new depth, okay? So that means if everything goes well, that now the buffer I have on the screen contains everything well, okay? So how much time? 20 minutes yet, so still I can do. Cool. So we have half of the ferret now. We are rendering only the whole scene. Like you can see, we are rendering these, I don't know, 50 draw calls. 50 is the number of objects we have on the scene as far as I remember, because 3 and 3 and the trash bin has a lot of them. So we are rendering the whole scene now, and only once. And then I'm rendering now this sphere. So I'm going to use this sphere to render the point lights. You will have to do the rest. You will have to do the directional light and the spotlights using Deferred, okay? Which is not very different from what I'm going to do, okay? So how can I enable the illumination? So first, I can use quads if I want to. Using quads is super inefficient, but if I want to, I'm going to use quads now because I don't have too much time. But if I was using spheres, it would be way better, okay? So I'm going to comment this one. Okay. So I'm going to use a quad so you can understand. So first step, which is rendering the global information, ambient and emissive, done. Second step, I need to iterate through every light, okay? So for every light, I want to render a quad, and for that quad, for every pixel, I'm going to compute how much that light affects this scene. I don't have a 4 for every light, as far as I remember. For light, auto light. Let me see if I have it here. It should be in this function. I did the loop, no? Yep, here it is. So something similar to this. I usually like to have a function to, I don't want to clone this code again and again and again and again. So I usually have a function where you just, similar to what I did for the camera, a function where you pass, where is it? Here, camera to shader. I don't know, maybe it's good to have a light to shader. So I pass a light, entity, and a shader, and it's going to fill it everything. So I don't have to type again the whole code. So here I have this function here. I'm going to clone it a little bit. So I'm going to bring here all the code I was showing you before, the, I don't know, light color, blah, 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 all this code here. Okay. Light to shader. So at least I don't have to copy code many times. Okay, this is way better. There's no error here. Cool. I was expecting that maybe there's going to be some error related to some missing parameter, but anyway. So in my deferred rend function now, I want to iterate through every light. Good that I separated the lights first, and it was something like this. I did prior, just to be sure I'm not missing any. Auto, oh, it's auto here without the asterisk. Yeah, I don't know how to put this because it's a pointer. Okay, so for every single one, I want to render a quad. Okay, but this quad will go with a different shader. So let's prepare the shader first, because they are all going to share the same shader. I'm going to use, I'm going to put outside. Okay. And then I have to pass all the information that which are going to need, which is, well, all the information about the shader, about the light. But also I need to pass information about the camera to reconstruct the position. So here is the tricky part. to reconstruct the position of every pixel, because we need the wall position to know if a point is close to the light or far away from the light. So if I need exactly the wall position, I will need to reconstruct it from the depth buffer using the trick I told you the other day. That means I need to have the inverse view projection. Okay, so I'm going to pass to this shader, set uniform, the U inverse view projection, okay? Which, by the way, it comes already in the camera. I put it here because otherwise, I mean, you're going to need it anyway, so I put it here. If it's not here, I don't know, I think it is here. Yeah, it is here. I was thinking in the versions, if it's another version, you can invert the view matrix and it's the same. Okay, so I'm passing this. So if I want to reconstruct the wall position, I'm going to create this shader, which is the last step of our big chain of actions. Okay, so let's go up. Then, for this one, should I use a quad VS or should I use a basic VS? Depending. If I'm going to use a screen quad, which is what I'm going to do, we use the quad VS. But if we're using some sort of a sphere, and then we will use the basic VS, because the basic is the one that multiplies by the view projection and all. So in this case, I want to go fast, so I'm not going to use that one. Okay, so here, this is going to be similar to the thing I did before, so I'm going to copy most of it, okay? But I'm going to read the depth buffer. If it's 1, I'm going to discard this pixel. I don't need to do anything. But I need the wall position, okay? So how do I compute the wall position? Remember the trick I was telling you the other day, which is if you have the inverse view projection, and you know the coordinate of this pixel in the screen coordinates, so in the screen coordinates is the x, the y of this pixel. How do I get the x and the y of this pixel? One way could be using the UVX and UVY, okay? UVX and UVY. There was a problem using this approach. I don't remember what was the problem. In the slides, you will see that I do another trick. But for now, let's try this. If it doesn't work, I will change it. And the third one has to be the depth. And the fourth one has to be 1, 0, 0. Now, I'm going to multiply. I'm going to put, here. I'm going to multiply this coordinate. This goes from 0 to 1. Okay, remember that on clip space, it goes from -1 to 1. So if it goes from 0 to 1, then we multiply by 2 and we subtract 1. Okay, and the same for the other one, for UV1. Okay, and for the Z, I think also it should go. I think also I should be doing like this. I'm not sure now. I would check on the slides 1 second, because I always forget about these things. So that's good that I have the slides here. So no, sorry, I have it here to reconstruct the wall position. Wall position. Here it says how to decompose. Yeah, I'm doing also for the Z coordinate. Well, I don't know if you can see it because my face is in front of it, but I also, because all the components, when you work in clip space, they go from -1 to 1. Okay, so I do this. Now it's ready. I multiply this according to the slide. I multiply. I can work prog. Okay, it looks better. I multiply by the inverse projection, which I'm going to put here. This is screen pose, and remember that this screen pose is not ready to be used. Because you have to, this is what's called homogeneous space, and you have to divide it by the W, which I don't understand why, but that's the way it is. So we have the wall position now. Okay, cool. Because we have the wall position, it will be always important to debug it to be sure that the wall position is right. So I'm going to remove, well, not, yeah, I mean, well, I don't need these things, but it would be nice to be sure that the wall position is right. So I'm going to say that the color is equal to wall position, because wall position has 3 components. Color, sorry, X, Y, Z is wall position. So at least I can see if this quad, when I'm reading the depth and everything, looks nice. Okay, so this is the Deferred light. We go to the renderer, we use the Deferred light, and we're going to render a quad for every single light. For now, I will disable blending, although I will have to enable blending later. But for now, I'm going to disable to not mess around with when I'm rendering. So let's see what we get here. We get a crash because, again, we are defining a variable that's already defined. Okay, everything it's green. That doesn't make any sense. And now it's blue. It's like all the pixels have exactly the same global position, which doesn't make any sense because every pixel should have a different global position. So let's go back again to my shader to be sure. That's super weird. So, by the way, I don't need the ambient light now. This is the deferred light, yeah. So let's check again. I'm using the UV in the examples. I don't use this UV, and maybe that's the reason why I didn't want to use this UV because there was maybe some error. But this goes from 0 to 1, I remember, and we multiply by 2 and subtract 2. So this is the screen pose, and we multiply the screen pose, and we'll position. Let me check the slides again. I'm going to use the same trick I use here, which is for the UVs. In the slides, I use this one, which is screen coord gives you the coordinate of this pixel in pixels. So this is the pixel is the, I don't know, 100, 100. Okay, so you divide it by the size of the screen. It goes from 0 to 1. Okay, but because I don't know the size of the screen, I usually have to pass it, and because I have to divide and divide it is slower than multiplying, I actually send the inverse of the resolution of the screen. So if you pass this, the inverse of the resolution, you just have to multiply. I don't know, I do this because I remember last year there was some sort of error, and I thought that maybe made more sense to do it like this. So use is vector of 1 divided by size.x and 1 dot divided by size.y. Okay, I don't think this is going to fix anything, but at least I want to know what's going on. Okay, and also it's killing all the pixels, which is weird because if I was reading the I'm silly. I'm changing the shader to this other shader, but I'm not binding the textures again. Remember that every time you change to another shader, you are forced to bind everything again. If you don't bind them again, well, it wasn't reading the right textures. This is a common error. And boom, we have the wall position. And as I was saying before, you try to show the wall position, you can read it because, I mean, it goes from 0 to 1, and then after 1, it goes it keeps increasing. So best way to show the wall position as a color is first, instead of going from 0 to 1, make it divide by 0, 0, 1 or something like that. So at least the gradient is bigger, but maybe too much. So there's more gradient here. So you can see that the 0, 0 has to be around here. And you can see how it goes from 0 to 1 on the green. So when it goes up the pixel, the higher it is, the more Y does it has. So it's greener. The more to the right is more red because the right is in this direction. And the more to the front is in this direction. And also, obviously, if it's negative, negatives are clamped to 0, so it's black. If you don't want to see the negatives, you want to see them also as color, one classical trick is you do the absolute of this. So you have also the negative as a color, okay? But if you want to have a way to visualize this like constantly, not because now it's going to burn also on these parts, you can do what I was doing before, which is you can do the F mod of this with, I don't know, 1.0. Sorry, I put vector 4, it's vector 3. So it's going to do, what? It crashed, sorry, it's F mod. No, it's not F mod, it's mod, sorry. It crashed the application, obviously. Remember that if your shader doesn't compile properly and you recompile it again, it's bad. So here, I was saying before, this is the how to visualize the global position. And so it's nice when you want to see if the global position looks nice, okay? And something you may see when you are working with the global position is check how the global position is starting to do some weird shit here, okay? This is something I'm trying to discover why it's happening. I don't know why it's happening. There's a problem on the inverse view projection, and when you multiply by this inverse view projection, and the Z has not very good precision, it gets crazy. And it shouldn't happen. I'm trying to debug it because it doesn't make any sense that this happened. So I will try to see if I'm doing I think that the function I'm using to compute the inverse has a small error, and this error keeps growing when I compute it. Anyway, so we have the wall position, and it looks nice. So what we have to do here, we do what we did always with every single light. We applied all the n.l, blah, 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 blah. Okay, so I want to have here the light position, the light color, the type of light. If you want to use all this information and you want to have to include it every single time, like for instance all this code here, okay, you can do something in my system. You can say here include oops, it was include or it's import, I don't remember now. Lights, I don't know, and then you can add a new here called lights. So when it finds this include lights, I don't know if it's include or it's import. Well, we will see. When it finds this, it's going to find this file inside here, and it's going to copy paste it here. Be careful, because my inclusion system is very crappy, and that means that if you include something that has also another include, it's not going to work. Only works if what you include only contains that one and nothing else. Okay, so by doing this, I have exactly copy pasted the code from the top to here, which is good. And then the only problem may be that, well, we will see. So I'm going to include also here. So I have all the variables for the lights. So here, remember that we're going to draw a full screen quad for every single light. So that means I only have to compute for this light now. And for this light, I don't know. We have the color I did the other day, all this code about if the light is directional, if the light is blah, blah, blah. I could also put this in the function, but I don't have time to do it now. So I'm going to copy paste this and just go with it. But it's always good to have everything separated, so it's here. Also, I'm going to need, for now, I don't need the extra color, because the extra color is the emissive, and I already have used the emissive. I'm going to leave it here, because maybe you need it for the fourth component, because you have put, I don't know, some information there. But I'm going to need the normal, so I'm going to have to reconstruct the normal. So I'm going to put here the code for the lights. And as I say, it's bad to copy paste code, because that means that you modify it in one place, maybe you don't not modify it on the other one, so be careful with that. And so I have this light. I'm going to remove this one. The ambient light, we don't need it. The ambient light was already drawn before, so forget about it. Wall position, be careful, because the name of the function is different now. It's called wall position. So we're going to call it wall position here. It's going to compute the shadow factor, and if the light x, blah, 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 it's going to compute the light, blah, blah, blah. So here at the end, we have the amount of light. And so for the final color, vector for color is going to be 0. So the color XYZ is going to be the amount of light multiplied by the albedo color. And the albedo color, we have it here. So it should be something like this, XYZ. And that's it. I don't think I need anything else. Remember that we don't need to put the emissive or the ambient, because we already have it. And the only problem if I do this now, it's not executing. It's executing, but well, I don't know if it's working or not. No, it crashed. Whoop. It crashed because there is a wall position with a V from the previous shader, and that doesn't make any sense. So crash. This is crashing inside here. This is bad, because it means I'm overwriting memory. I will have to see that. Anyway, here there is a place where I say wall position. Remember, now it's wall pos. So wall position here. I don't think I'm doing it anywhere else, that thing. Wall position. Gone, light, attenuation, shadow factor, boom. So, okay, should work now. Oh, so you can see I'm only seeing the spotlight. Why I'm only seeing the spotlight? Who can tell me why I see only the spotlight and not the point lights or the directional light? Any ideas? And with that, we finish it, because we are on time now. Any ideas? We are only seeing the spotlight. We should be seeing all the lights, because I'm iterating through every single light. So I'm rendering a full screen quad with every single light. And for every single light, I'm computing how much light does it applies. No ideas, no suggestions. Why only one of the lights, not all of them, although I'm iterating through all of them. Maybe if I show you the code, you can spot something weird here. Remember, we're iterating through every single light and render a full screen quad for every single light. So where is the problem? Come on, you have done this. You did it for the first assignment. How do you do to accumulate many lights? Because we are not blending. I mean, if we don't blend, it's going to overwrite what's written on the image every time. So you are going to see the last quad. So obviously we need to use blending, because if we don't have blending, there's nothing to do. So I'm going to stop this. I'm going to enable blending. So first light, we shouldn't have blending. Second light, we should have blending. Okay. So I disable blending here before. I'm going to do the trick we did before. I disable blending here, and I'm going to enable it here. And also, when you use blending, in this case, I want to have additive blending. So I'm going to use GL blend function, and I'm going to put here GL source alpha, which doesn't make any sense, source alpha, because the alpha is always going to be 1. But anyway, I put source alpha 1. Okay. And at the end, always when you enable blending, at the end, always disable it again, because otherwise when you render something afterwards, it's going to crash with that one. Okay. So because we have blending now, not for the first one, but sorry, by the way, the first one should have blending. I did an error here. Why should the first one has blending? I assumed that the first one wasn't not going to have blending, but the second iteration and third iteration of the light, for every single light after the first one, we're going to. But we need blending from the first one. Why? Because of the ambient light. Uriel is right. Because remember that we already have illumination. We have the emissive and the ambient on the screen. So if the first one is not blending, it's going to destroy that one. So oops. So this is out. This goes here. Okay. And now we have everything. We have the skybox. We will have the ambient, the emissive, and every single light, all using less draw calls. Okay. And it's not working. Cool. 1 second, what I did wrong now. Enable blending, I blend source alpha 1. Also, when I'm rendering now, I don't know if the depth buffer is enabled or disabled. This disabled here. I modify it here. When I render the global, I'm going to disable it now, because I'm not sure that when I render the quads, I mean, I don't need to do any depth test now for the quads. If I was using spheres, yes, but not for the quads. So okay, that's weird. That's super weird. It's weird that one of the lights, if I enable and disable lights, let's see what happens. God damn it. Why is it not working now? So I enable blending. Let me try this just to be sure. Enable blending. Blending function is 1, 1. Maybe blending function, yeah. It was that one. Yeah, I'm silly. I say to use the source alpha, but if I go to the shader, probably the source alpha is 0. See, color 0. That means that it's put 0 on 4 components. If we put 0 on the on the 4 components, the alpha is 0. If the alpha is 0, and I don't know modify because I only modify the RGB, not the alpha, I was rendering pixels with alpha 0, which is it's not bad. I mean, the problem was that here I was saying use the alpha to multiply these pixels. You multiply by 0, it's 0. So 2 options. Or I put source alpha here, GL1 here, so it's going to ignore the alpha. Or if I use the source alpha here, I have to be sure that this has alpha 1, which was a silly mistake. And with this, we have it. We have a deferred renderer that is rendering the scene first, and then it's rendering all the objects. You will see these artifacts, by the way. Okay, I don't know if you can see these strange artifacts on the stream. Okay, here. And this is the problem is that when you reconstruct the wall position from the depth buffer, it's not exactly accurate. There's always a little bit of error. That means that every pixel he thinks could be a little bit closer to the camera or a little bit farther from the camera from what that pixel was really there when I was there. And there's a lot of ways to mitigate this. One of the things is you don't use logarithmic depth buffer, which is the one that comes from default. You use a linear depth buffer. The problem of using linear depth buffer is that the code gets a little bit more uglier, and I don't want to use that. that. So because the position now of these pixels are not exactly right, that means that when it computes the shadow map, it thinks that this pixel is closer than the position on the shadow map, so he thinks there's something occluding, so it's showing here occlusion. One silly way to fix this, increase the bias. Okay, you increase the bias on the lights, in this case the spotlight, you increase the bias, this artifact disappears. Be careful, because if you increase it too much, it's going to also appear, you're going to destroy it with the shadow map. Okay, so this is one of the problems we are going to face. And also we have the other problem I was telling you before, which is when you're far away, sometimes the wall position is so bad that the lights can start doing very strange things, like, I don't know. Okay, so you can see 53 draw calls, and we have exactly the same. And if I go to the other one, to the lights, boom, 157, and it exactly looks the same. The only difference is that we have the alpha objects. Okay, you can see that I don't have the alpha objects on the Deferred. Okay, so for the alpha, as I said, there's two options, or you render them. You can, one of the tricks is, if you want them, is now when I'm rendering this, you can also add here the function that you call to render all the alpha objects here, and because the depth buffer is right and everything is right, it will render the alpha right. You can do this if you want to. So you render exactly the same as in forward, but only for the alpha objects right on this line of the code. Okay, after I have done everything else. That's one option. And the other option is to use dithering, so some pixels you render, some pixels you don't render them. It doesn't look so good, but most of engines do that, so you can choose. Okay, so this is going to be the second assignment. You have to implement the ferret, and you have to implement it not with full screen quads, because remember that we are rendering full screen quads for every light. Even if the light is tiny on the screen, we are rendering a full screen quad of computing, reading all the texture, 4 textures per pixel, which is horrible. Okay, so the next step should be doing something similar to what I did here. Okay, you're going to create a sphere, and the sphere is going to be rendered in a position. In this case, I didn't put any position, but you can position on the position of the light. You have to use a different shader for the vertex shader, because this one will have to use the model and the view projection of the camera, and that means that you can position the sphere wherever you want to. So it's going only to apply the pixel, the illumination, or the shader of because for the color you will use exactly the same shader. So for the spheres, you're going to use the pixel shader is going to be exactly the same. Okay, this one, but the vertex shader will be different. Okay, and for the, by the way, for the spotlights, I recommend you to use a sphere that is as big as the max distance on the spot. It would be better if we have a cone, but I don't have a geometry to construct a cone based on the fob of the spotlight. So anyway, okay, and for the directional light, it doesn't make any sense to use a sphere, because the directional light affects everything. So for the directional light, obviously you have to use a full screen quad. It's the only one where you have to use a full screen quad. For the spotlights and for point lights, you should be using a sphere. Okay, so that's it for today. Now you have a little better understanding of what the Deferred Render is, and how, just by playing around with the things we have already, how to play intelligently with the buffers and with BOs, with the shaders, with the reconstruction and all those things, you can construct a very interesting render pipeline that is way faster. But as I said, there's faster render pipelines. Okay, there's the tile one, there's the clustered one, that they go more specific to only apply illumination to some of the pixels, because now we are still wasting some resources. When you draw a sphere, even with a sphere, you're wasting some resources. Okay, so that's it. I hope you understand better today what's the ferret in comparison from what I explained yesterday. And well, you can start implementing it in your engine. You don't have to keep working all the features. Like, you don't have to have the ferret with single pass or multi-pass, something like that. No, you just now have an option to render the ferret, and you have to be sure that the ferret looks as similar as you did for forward. And remember always to refactor a little bit your code. So if you see any functions that you used previously that you may want to reuse again, don't copy paste code. Try to abstract a little bit the things. Okay, in my engine, for instance, the one I was showing you before, I have a tiny set of functions. I reuse them a lot with in the ferret and in forward, and it works super well. Okay, so that's it. Any questions? I guess not, because you are not very personal. Oh, nice. Uriel has a question. So if you have to keep working on the previous assignment or move to the new one, Depends. As I say, Shadow Atlas, for instance, is an example of something that if you code it, it makes everything easier. So I would recommend that you do the Shadow Atlas if you have some time, because otherwise, well, doing the ferret maybe could be a little more complicated. But as you wish. I mean, I'm going to evaluate the first assignment, and I'm going to evaluate again. Obviously, if the first assignment you do something and on the that you forgot to do something, or you don't have time to do something, and you do it on the second assignment, I usually like to check when I have the grade. If I see that you already have done this, even though you didn't do it in the first assignment, I will give you the points. So you didn't do the Shadow Atlas on the first assignment, but you do it on the second assignment, I'm going to give you the grade, okay? So it's good to do it. But obviously, these things, I better prefer that you do it after you have done the second assignment, okay? So don't waste now time doing things from the first assignment when you have things to do from the second assignment. So start with the second assignment, and if everything goes well, use that time to do the first one. As you can see, the Deferred Renderer is quite simple. What I did today is almost 90% of what you have to do. But the second assignment will have more things, obviously, not only the ferret, you will have also to make a new pipeline for materials. So try to do this one. I think this one is easy if you understand it. Try to do the ferret this week, and then you can put the other one on. Yes, you're right. I forgot to say it. The second assignment is in groups, okay? So that means that yeah, the thing I say about not doesn't apply, because if you make a group with somebody who's done something on the first assignment that you didn't do on the first assignment, I cannot know if you did. But anyway, make groups of 2 if you want to for the second assignment, and if you want to bring things from one of the codes of one person or the other, you choose. Okay. And if you want to do the things you missed on the first assignment, you can always send it to me and say, hey, I did this feature, I didn't have time to do the time. Cool, that's it. We leave it here. Any questions? Discord, put screenshots on Discord. It helps a lot, because if people see your code, your images, they can understand what they should be doing. Okay, so keep working on that, and maybe I will export the demo scene I was showing you before if somebody wants to load it to test it. I did it procedurally, like by code. I make a for loop that instead a lot of cars. Maybe it's useful for you to have it. Okay. That's it. See you next Monday for questions about the ferret. And remember, next week we will move to something totally different from the ferret, so you better have something done. See you next week. Bye.